We're going to take the inverse variation equation, y equals something divided by x, and mess with that equation a little bit. This used to be an exploration, but now we've put in some screenshots from the graphing calculators so you can see a little bit of this without having to actually graph it all yourself. So we are first going to look at this type of equation. Y equals a divided by x minus h plus k. When you graph this type of an equation, it gives you a hyperbola. Kind of like a parabola is not a parabola, a hyperbola is not a hyperbola. It is a hyperbola. Do we all need to say it together? Hyperbola. It is a hyperbola. A hyperbola is a two-part graph. It looks like two little C-shaped curves diagonally from each other. And there are two asymptotes. There's a horizontal and a vertical asymptote. So the first thing that we're going to look at today is, where is the vertical asymptote? Where is the horizontal asymptote? And can we find that in the equation? So let's start with vertical. In this graph, there is a vertical asymptote right there. Where is that vertical asymptote? At 3. X equals 3. Can you see 3 anywhere in the equation that was graphed? Think about, if you plugged 3 into this equation, what would 3 minus 3 give you? 0. Can you do 2 divided by 0? No, you cannot divide by 0. So the vertical asymptote occurs when the denominator equals 0. So whatever x value would make the denominator equal 0, that's going to be your vertical asymptote. And that is also tied to the domain. The domain is always the x values. Notice there are points to the left of the asymptote. There are points to the right of the asymptote. The only place on this graph where there are no x values is that asymptote. So the domain is x cannot equal 3. When you write x cannot equal 3, it's assumed that all of the other real numbers do work. The only real number that doesn't work is 3. Now let's look at the horizontal asymptote. This appears to have a horizontal asymptote right there. What are the coordinates of that horizontal asymptote? Y equals 4. Anyone want to take a guess what the range is going to be? Y cannot equal 4. There are points above and below the asymptote. There are no points on the asymptote, so y cannot equal 4. Take a look at the equation. Do you see 4 anywhere in the equation? Okay, so I tried to color code everything so you can see where things come from. So if I took this graph out on number 2, do you think that you could find the vertical and horizontal asymptote just from looking at the equation? Okay, so if we look at this equation, on the bottom it says x plus 3. So what do you think the vertical asymptote is going to be? Okay, because negative 3 plus 3 would give us 0, and we can't have 0 in the denominator. And if we look at this graph, we do have a vertical asymptote at negative 3. And that means that the domain is going to be x cannot equal negative 3. All right, what do you think the horizontal asymptote is going to be? Negative 1. So y equals negative 1. And the range, y cannot equal negative 1. Now I do want to talk for a minute about why there are asymptotes. So the vertical asymptote is because we can't divide by 0. So why in the world is there a horizontal asymptote? If I put negative 1 in over here, so if I had negative 1 equals 2, negative 2, over x plus 3 minus 1. If I have -1 on both sides, that means that this thing would have to equal 0. In order for this equation to work, that fraction would have to equal 0. The only way to make a fraction equal 0 is if you have 0 on the top of the fraction. But we don't have 0 on the top of the fraction, we have -2. So there's no way to make that fraction equal to 0. There's no way that the right side and the left side can be equal if our y value is -1. That's why that horizontal asymptote appears. It's probably something that you won't remember, but at least I've told you, so that makes it better or something. From this, we can conclude that the vertical asymptote is h, or you might want to jot in your notes whatever number makes the denominator equal to 0. The horizontal asymptote is k. So, using what we just learned, we need to graph this equation, y equals 1 divided by x plus 2 minus 4. The first thing that I want to do is look at the vertical asymptote. So if this says x plus 2 on the bottom, what is the vertical asymptote going to be? X equals -2. And that means we automatically know that the domain is x cannot equal -2. Let's sketch that asymptote in. What's the horizontal asymptote going to be? So our range, y cannot equal -4, and we can draw in our asymptote. Now, back in my day, we didn't have, we weren't allowed to use the graphing calculator to help us with this, so we had to pick numbers to the right and to the left of the vertical asymptote. So pick -1 and 0, pick -3 and -4, and plug those numbers in to get the corresponding y values and then graph them. I am going to let you take a shortcut and use the graphing calculator. So in your graphing calculator, you need to make sure you know how to enter this into your calculator. The important thing is to put parentheses around the denominator. So 1 divided by parentheses x plus 2, close your parentheses, minus 4. And if you want to look at this graph, you absolutely can push the graph button and look at it. It should show you that you were correct in our guesses of the vertical and horizontal asymptote. It shows you that the graph is going to be on the upper right and the lower left of those asymptotes. Second graph to go into the table. You'll notice the vertical asymptote says error. So remember that you can't use that x value. That's why the calculator is telling you error. You want to pick 2 points on either side of where it says error. So our asymptote was at -2. I'm going to pick -4 and -3. -2 would be that asymptote right there in the middle. And then -1 and 0. So -4, -4.5, -3, -5. Now, if you want to, you can grab more of these points and you can graph more of these points. But take a minute and at least get these 4 points on your graph. You can include more points if you would like. The other type of hyperbola we're going to look at is of this form. Y equals ax plus b over cx plus d. It's one big fraction instead of a fraction with something added or subtracted. So let's look again at the vertical asymptote. at this graph, the vertical asymptote is here. And that has a value of negative 4. So x equals negative 4. Do you see negative 4 somewhere in that equation? On the bottom. The vertical asymptote is still when the bottom would equal 0. Even if it's complex and says something like 2x plus 5, if you put the bottom equal to 0 and solve that equation, that will give you the vertical asymptote. The horizontal asymptote here is 2. Y equals 2. Where do you see 2 in that equation? Okay. What number is in front of the x on the bottom? Nothing, which means there's a 1. The horizontal asymptote comes from taking the coefficients of the x's, a divided by c. So whatever number is in front of both of those x's, do the top one divided by the bottom one, that will be your horizontal asymptote. The domain is tied to the vertical asymptote. X can't equal negative 4. Y can't equal 2. So that stuff from the first page is still the same. The only difference of this type is that the horizontal asymptote is the coefficients of the x's from the numerator and the denominator. So I want you to try number 5 on your own. For the one that we have to graph, before we enter it in the calculator, let's look at the vertical asymptote and the horizontal asymptote. The vertical asymptote comes from when the denominator would equal 0. So what x value would make x minus 3 equal 0? Positive 3. And then you can go ahead and knock out the domain at the same time. So x is 3. The horizontal asymptote is the coefficients of the x's. It looks like we've got a good old 1 divided by 1, which is 1. So our range, x cannot equal 1. I gave you a tip on how to enter this in your calculator. You have the entire numerator in parentheses and the entire denominator in parentheses. So enter that in your calculator, get points, and graph this. One of my students pointed out an error that I made. The horizontal asymptote is y equals 1. The range is y cannot equal 1. Sorry about that. My bad. What if we have this equation? The vertical asymptote comes from when the denominator would equal 0. And this time it's not super apparent. You may have to set the denominator equal to 0 and solve the equation. So we'd add 1 on both sides and then divide both sides by 5 to get a vertical asymptote of 1/5. It is possible for your asymptotes to be fractions. The horizontal asymptote comes from the coefficients of the x's. What is 2 divided by 5? Honestly, just right. Y equals 2/5. If you want to change it to 0.4, you can, but you don't need to. Just put those numbers in simplified form. So 2/5 is the horizontal asymptote.